evening.
Good
In the
evening.
yeah, in the last session we have discussed on FIFO, right? Sorry, finite state missions, right? So did you got the clarity? And also I have shared one link. Have you gone through that example? 0110, I think.
Yes, I've gone. I've done that
Did
in
you
EDA
got the
Playground.
output?
No, still it is actually. I mean, I've done in the EDA Playground, but my output is still not. I didn't get. But yeah, I'm trying to solve that.
Okay, fine. Some more examples we will discuss on Friday session regarding finite state missions. Today we will complete memories, okay? How to design RAM and FIFO memories. So mostly by today we are going to complete the Verilog HDL, okay? Friday session is totally discussing on all the topics. Just I will ask questions one to one, and also there will be a mock for everyone. Okay, so whenever you are free, let me know this Sunday, Saturday, and Sunday, morning or evening, from 10 a.m. to 7 a.m. Okay, so whenever you are free, let me know your timings so I can take mock for Verilog. Okay, till now, whatever you have learned and theory wise and also practical questions, so that I will give you the feedback. Okay, so till up to now, what's your knowledge and where you need to improve, I can give you the feedback. Okay, so Saturday, Sunday. Meanwhile, revise all the topics. If you have any pending works, complete all the pending works. Okay, and also from Monday onwards, we are going to start system Verilog. Okay, and I already told in the group, right? From next Saturday, not this Saturday, next Saturday, March 22nd onwards, we are going to start protocols. It's a weekend sessions, Saturday, Sunday sessions. Okay. So every Saturday and Sunday, there will be two sessions, one session Saturday, one session Sunday. Mostly I already told the timings, right? Morning around 11 o'clock. Okay, so 11 to 12:30 or 11 to 1 o'clock, the mostly the timings will be in that. Okay, so we are going to discuss weekly one protocol. First week will be the introduction on protocol. Second week will be yacht. Third week will be I2C. Fourth week AMBA APB. Next day HBA. Next day XI. Like that. It will be taking 1.5 month to complete the protocols. Okay. These protocols are totally system Verilog and UVM development. Okay. So if you want to join only for theory, to understand the theory, you can join. If anyone have some basic idea on system Verilog, meanwhile we will complete system Verilog also. By APB protocol, we will complete how, like overview you will be getting understand. Okay. So you can join for both the lab session and theory session. Okay, so as of now, try to understand mostly theory for all protocols. At the end of your course, at the end of system Verilog and UVM, again we will discuss on protocols. Okay, as of now, just another batch is going on. That's why I am telling you to join parallelly. So if you want to apply for jobs or internships, you can put in your resume parallelly, right? So try to attend. And what are the leftover topics from digital logic design, CMOS topics, and static timing analysis, right? From March 15th onwards, we will discuss static timing analysis. Another PD engineer is going to discuss on these things. Okay. you will get access for 2 sessions, 2 or 3 sessions. Actually, it's total 15 sessions, but you will be getting 2 or 3 sessions access, okay, for static timing analysis. So that is the schedule for next 1 month. Clear, everyone? Any doubts? Hello. So today we will start with the memories. Any doubts till now in Verilog HDL? Guys, from registers, counters, finite state missions, any doubts? Are you able to
Uh,
write?
so,
Yeah, tell.
uh, Prasanti, I'm doing the counters assignment. In that, can we discuss just few thing in assignment?
We will
Uh,
discuss at the end of the session.
okay.
Do you want to share your screen?
No, sorry, my screen is in the different laptop. So,
Okay. So we will
I mean,
discuss it.
just there in the counters, some questions are they are telling that mask there means skipping or something
Mask
like.
is also similar to the skipping. But
Oh,
skipping means what? We will just multiples of 3. Whenever we get the multiples of 3, we will just skip that and we will write remaining.
yeah.
Mask is also same as similar to the skipping, but we don't print separately remaining all numbers, and within the same we'll just take with extra clock cycle and we just print separately. That is what mask.
Sorry, I didn't get clearly. I
In the
mean,
skip we just remove.
yeah.
In skip we will just remove the multiples of 3 at 1 clock cycle. In mask we will remove the multiples of 3 and
Hmm.
also we will print separately. 1 clock cycle is for printing multiples of 3, second clock cycle is removing the multiples of 3 and printing remaining
Oh,
all numbers.
okay,
You need
okay,
to use 2 clock cycles here.
okay. Okay.
Okay.
Thank
Next, coming to the memory modeling in Verilog. So how we are going to design different types of memories. Today we will look into it. And if you see how many type of memories are there in digital logic design, we already discussed, right? How many types of memories are there?
Cache, primary memory, secondary memory.
Primary memory, secondary memory. Okay. And
We will have static and dynamic memory.
static and dynamic memory. Okay. Is it in digital logic design? I'm just asking like RAM, ROM. We have different memories like sequential access memories, random access memories, right? Like that.
Um,
Hmm?
I told overall.
Okay. So what is the use of memory? What is the use of memory in microprocessor or microcontroller? Is the memory and register both are same?
Series of registers we
no,
call it as memory.
Hmm?
Group of registers we call it as memory. And both are used to store data only.
Okay. Group of memories we call as a group of registers we call as a memory. Okay.
Yeah.
So what are the different memories like main memory, RAM? Main memory we call as a RAM. Then what is a ROM? We have volatile and non-volatile memories. Okay, so registers are also a type of computer memories. Okay, so in memories, like whatever the RAM, there will be same, like registers are small and also fast storage units within the CPU, but memory is a larger and also slower storage area for data and programs which are using in the CPU. Okay, so comparing to the register and the memory, mainly registers used for holding data and instructions that are being actively used by CPU during data processing. Okay, but memory means what? It just stored the programs and data that CPU may need. Whenever need the access, it just stored the data and process the program. Okay, so that is what main memory or RAM we can call. Within the processor, actually we have two types. One is a register, one is a cache memory. Primary cache will be there in the processor and secondary cache will be there in the separately. Main memory, secondary memory, all these will be there in the separately. Okay, so in main if you see how actual computer system architecture will look like, there will be a central processing unit, CPU. In CPU there will be control units, there will be lot of control units, ALU, arithmetic and logical units, and there will be different types of special purpose registers, and general purpose register like program counter, accumulator, or these R1, R2 general purpose registers. All these things will be connected to the memory. So registers are different, memory is different. Memory means we have RAM or ROM, secondary memory or primary memory, like that. Okay, in main memory we have RAM and ROM. So here we have the RAM memory and ROM memory. In CPU, basically we have the registers. Registers means it stored the instruction data. You already know assembly language programming. How do we write the assembly language programming? Add R1 comma R2 comma R3, subtraction R1 comma R2 comma R3, like that we store into the general purpose register. That instructions will be processed in the central processing unit. That type of data we will store in the registers. Okay, but memory means mainly we have the cache memories or RAM memories in the main memory. Okay, now clear everyone? Next, what is the use of semiconductor memory in microprocessor and what separates a microprocessor with a microcontroller? What is the difference between microprocessor and microcontroller? Can anyone tell what is the difference? What is the difference between microprocessor and microcontroller?
Microcontroller, we can call it as a small computer to perform some specific operation, whereas microprocessor means we can interface a few other devices for the multiple purposes.
Okay, others, any answer? No, no idea. Okay, microprocessor means it will be used in the CPU. CPU will be embedded into the processor, like where it do the specific operations, all type of general operations it can be done. Microcontroller means it will be having processor, RAM, flash memories, and also different type of peripherals will be connected to one one microcontroller. Microcontroller means it's like a kit. Arduino board will be there, right? Raspberry Pi. Raspberry Pi is also one of the microcontroller. Okay, so microcontroller means it doesn't do all type of operations like processor will run all type of instructions, okay, but microcontroller will do only specific task, okay. Processors are like in our mobile phone or computer, we are using everywhere the brain of the computer. It's a brain of any digital logic circuit, okay. But controller means specifically, suppose if you see number of applications like washing machine or the AC refrigerator, it do only specific operation, okay. So like my refrigerator does not work as a AC, and the microwave oven can't work as a refrigerator. So according to the specific application we write the program. But processor means it just have normal programming, general programming, like which do the arithmetic and logical operations. It do both, okay. But controller means only specific. According to your application we dump the program accordingly, okay. So that is what the difference. And is the register is also memory, we already just discussed the difference between register and a memory, okay. So if you see here the classification of memories, these are the different types of memories. We have semiconductor memories and also other forms of including optical, magnetic. Suppose these memories comes under suppose, if I don't know whether you remember or not, in your childhood days, if you see the tape recorders, reels will be there, brown color reels, magnetic tapes will be there inside the tapes. Mostly in radio or tape recorders, we'll get some music, right, through that the recorder, the tape recorder will be it will be running in a circle motion. So how it will be running, we store that data in that magnetic tapes, okay. Like that optical tapes also, that is one type of storage device in olden days, okay. It doesn't work effectively, but we can process the data, okay. But another type of memory is a semiconductor memories. In semiconductor memories we have two types. One is a sequential access memories, one is a random access memories. Sequential access memories means, first I will tell you random access memory. So random access memory means, suppose here it is a memory, okay. First of all, what is mean by memory? It stored the data into the number of locations, right. So suppose it's a memory, it have n number of locations like this: location 1, location 2, location 3, location 4, like that. So these locations we can also call as a address pointers, okay. Both are three or same, we can also call as a location or address or pointers, okay. So 0th location, first location, second location, third, fourth, fifth. So based on your size of the memory we have those many locations. Suppose 3-bit size, 3-bit size means 2 power 3, 8 number of locations. 4-bit size, 2 power 4, 16 number of locations, like that. 5-bit, 32 number of locations. So in each location you are going to store some data, okay. So 0th location you want to store some data, third location you want to store some data, and then in 6th location you want to store some data. So where we are storing the data, it's nothing but a memory. It's a group of locations, group of addresses, okay. So while you are storing some data to the memory, we need to follow some rules, okay. So one is a RAM, another one is a ROM, okay. So RAM and ROM, this comes under random access memory. Random access memory means we can access the memory randomly, okay. Suppose if you want to store data into some 10th location, means directly we can store the data into the 10th location. We no need to come from 0th location, you can directly access 10th location. Like that, if you want to store data to 5th location, directly you can access 5th location, okay. That means random access. We can store the data randomly, and also we can read the data, write the data, read the data. Write the data means what, we are storing into the location, okay. Read the data means we are retrieving the data from the memory, we are getting the data from the memory, so outside. Okay, so that is what random access. And coming to the sequential access, we have two types. One is a FIFO memory, one is a LIFO memory. FIFO means what? First in, first out. LIFO means last in, first out. Okay, so first in, first out means suppose uh, whatever we kept first, whatever we are storing first, we need to retrieve that data first. Okay, suppose there is a ticket counter. Okay, whatever the ticket counter, we are going in a queue. Okay, so first first person is going, second person, then third person, like that one by one in a queue we are going. So whoever get the ticket first, I will just a second, I will get back in 5 minutes. Hello, are you there?
Yes, ma'am.
Yeah, sorry.
Yes.
So coming to the FIFO memory, suppose it's a first in first out. Okay, suppose we are going in a ticket counter, so one after another. First, whoever went, that person will get the ticket and will come back. Okay, and second person, whoever went second, then second person will get the ticket and come back. And then third person. Okay, so first in first out. So whoever went first, they can access that particular data and get back. Okay, in the same way, it's a sequential access. Sequential access means what? Before, in random access, the memory locations we can able to access randomly. Okay, whether it's a write data or read data, you can pick any location according to your usage. Whatever the location you want to store some data, you can directly access that particular location. Okay, but in FIFO or LIFO, last in first out. LIFO means last in first out. That means whoever went last, suppose first, second, third, fourth, the data is going in this format. Okay, the write operation, but retrieving the data will be in this format, last in the first out. So whoever went last, that will be first. Retrieving will be this direction. Okay, both are sequential access only. We cannot access the data randomly. Suppose in a FIFO memory, here it's a 0 location, first location, second location, third, fourth, fifth, sixth number of locations, six number of address. Okay, so whenever you want to store the data, first we need to start from 0th location. In 0th location, you are storing some data called 50, and next first location only you need to store the data. You cannot skip to 5th location or 6th location. Randomly is not possible. Sequentially you need to access the memory. Okay, so first location, suppose if you want to store the data 60, and in the second location, if you want to store the data 30, in third location you want to store the data 45, like 67, 28, 23, like that, sequentially one by one, by using the pointer, like counter logic. You already know the counter will count number of clock cycles, not only counting number of clock cycles. In this case also, to increment one by one, suppose 0 plus 1, the pointer should move from 0 to 1. So 0 plus 1, 1, and then pointer should move second location. So 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4, 4 plus 1, 5, 5 plus 1, 6. Like that, the location, the pointer will be moved from 0 to last location. Okay, so this is what the FIFO. Okay, mostly why do we use FIFO memory? Can you tell me any applications for FIFO memory?
When working with different clock domains, or when the read or write domain is working at different frequencies, like if one is working faster and the other one is working uh, slow, to store
Okay.
data, we can use FIFO.
Okay, okay, fine. So mostly, suppose there are two type of devices. One is a source, one is a destination. Okay, so you are transmitting the data from source to destination. Okay, so maybe source will work at some frequency, and the destination will work at some frequency. Okay, if both doesn't have the same frequency, if both source and destination are not working at same frequency, what are the limitations we'll be getting? What are the major issues we can face? Suppose the at the source side it is working at a very high speed. Okay, per 2 seconds we are able to send the 10 number of transactions. Okay, destination side it is working at a very less speed. Okay, so for 10 seconds we can able to get the 10 number of transactions. Okay, but here it is giving fastly, but driver here whatever the destination is not able to access the data fastly. Okay, then what will be the major issue? first thing is a data loss. Okay, if you are sending fastly but receiver is not accepting, that means in the middle time the data will be lost. Okay, so without happening that, we use the FIFO concept here. Okay, FIFO is just a memory to store the data temporarily. So here it is sending 10 number of transactions. The 10 number of transactions will be stored in the FIFO memory. Okay, driver here destination is working slowly, right? So here at destination, one transaction is completed, whatever the time. It can take any time to complete one transaction. Okay, after completing one transaction, then it will be getting second transaction. After completing second transaction, then third transaction, then fourth. Like that, one by one transaction it will be getting from the FIFO. Okay, meanwhile FIFO will store that particular data in it. Okay, so that is what FIFO concept. In FIFO calculation, depth calculation, we have different types. What if the speed of source is high compared to destination? If speed of source is less compared to the destination? If speed of source and destination both are equal, then what is the comparison? Yesterday, if you see in my LinkedIn, I have posted this FIFO calculation, FIFO depth calculation. Okay, so if you already know, just go through that. If you don't know, I will share you that PDF. Just go through that. Okay, so you will understand the FIFO calculations are most important for interview point of view. Okay, very rare questions. All questions, all companies mostly they don't focus, but if you specially mention in your resume, maybe you will get the questions regarding the FIFO depth calculation. Okay, that's why just to have a look into that PDF, so you will understand. Okay, so this is what the FIFO application. Okay, so here this is how we are going to store the data into the FIFO memory. Okay, clear everyone? Did you understood what is meant by sequential access and random access? FIFO we will discuss more clearly while writing the program. Any doubts still here? No?
I have a doubt.
Yeah, tell.
Ma'am, you told that RAM is storing the data and instructions of the current execution that the CPU is doing. What about ROM? Like what it stores?
RAM is storing instruction of current memory. Yeah?
Current whatever instruction is being executed by the CPU, it is storing the data and the instruction. But I didn't get what ROM is ROM is storing.
RAM, ROM, they doesn't store the data from instruction. Registers will store the data. RAM and ROM are normal registers in a memory, main memory. In main memory, we have RAM and ROM memories. One is a permanent, one is a volatile and non-volatile, which can be erased data, and one is permanent. But in CPU, in the processor, we have the registers. In processor, we have the cores, cache memories, right? Cores, how the cores will be operated through the instructions only, right? We design the cores through the instructions. Okay. RAM and ROM comes in a memory, main memory or primary memory.
Okay.
Okay, clear? And also in RAM and ROM, we have different types. One is DRAM. DRAM means dynamic memory, dynamic RAM, static RAM, and here fixed RAM, fixed ROM, programmable ROM. And in programmable, we have PROM, EPROM, EEPROM. You already know these names, right? EAPROM, flash memory. Mostly in RAM, in current generation, in the industry, mostly we use these single data rate, double data rate, DDR memory we call, DDR2, double data rate to second version. double data rate 3, double data rate 4. These all are complex memories. Okay, but once by end of this course, if you want to do, we can do on these memories. Anyway, we are going to design the system on chip, right? In system on chip, we'll have the RISC-V processor, DMA controller, the memory controller, and this DDR memory will be there with the protocol interconnect. There we are going to design this. Okay, but today we will.
Prashanti, what exactly RAM and ROM contains? So volatile and non-volatile is fine. Random access and read-only memory, but what exactly it contains? Can you please explain?
Both are storage purpose only.
Yes, in that storage, what exactly it will be?
Exactly, in the sense that the data which you want to, like, mostly RAM have the short-term memory. ROM have the permanent memory. Okay, it stores the whatever the current usage data is there, like instructions. It stores the instructions from the starting of the computer. ROM.
Okay.
Mostly whatever the programming data is there. ROM in the sense it's a permanent, right? Permanent in the sense at the starting of the data, at ending of the data, it should memorize the data. It should not lose the data basically. So whenever the programming, the start of the computer is there, whenever the programming is enabled and disabled, everything it will be stored in that particular memory. It's a permanent, we can't erase. But in RAM memory, it's a volatile, means the data will be lost. Whenever the computer is shut down, the data will be lost. So whatever the instructions temporarily you are running, some application related data will be stored in the RAM.
Okay. Yeah.
Only programmings which are running the processors, multiple files you are running at the same time, those things will be stored in the RAM memory. But ROM memory contains the computer BIOS majorly, and also boot up process. Boot up also the permanent thing. Whenever the system is running, the whole time the boot up process will be there. At the starting initial stage also, the boot up process will be there. So all these things comes in the ROM memory.
Yeah, thank you.
Ma'am, where is the OS stored? Is it stored in RAM, ROM, or it is in HDD or SSD?
BIOS memory I heard, but OS I don't know whether it is in RAM or ROM. We need to check.
Okay. So when the computer first we power on, so the OS has to be loaded.
Yes, OS means it's a permanent, the boot up process will be done before the OS, right? Before operating system is on, boot up will do first, and then it will be going to OS. Then only will the Windows will be shut down or shut on, right? So mostly it will be comes under ROM. Boot up process in ROM means obviously OS also comes under ROM only.
Okay. Okay, ma'am. Thank you.
And also in RAM, mostly the temporary data storage or whatever we are storing some firmware, the system instructions will comes under RAM. Okay.
Ma'am, cache memory comes under RAM, right?
Cache memory is a different. It's not either RAM or ROM. Cache memory is a separate. RAM means it totally erased, but cache means what? It's a it just like fastening the process. Like it stores. It's a separate memory. Like to make the process speed, it just store the data in some memory. So whenever we just give the hint, suppose whenever we are typing in Google, already we have the predefined whatever we used before we get that options down, right? So
Yeah,
those things will be
history,
stored
right?
in the cache. That means it already storing some data regarding that, and for quick access, it just give the hints related to that.
And the speed of processor is dependent on cache then.
Yeah, sorry.
Speed of the processor.
Speed
Speed
up
of the
processor.
processor. No, ma'am. Speed of the processor.
Speed of the processor. Okay.
Yeah.
Speed of the
Which memory we will be taking care for the speed of the processor.
speed will be totally depends on not memory. Memory is just a storage purpose. The speed is totally depends on at what clock cycle we are using the clock edge frequency. That is totally different. At what
Okay.
bandwidth we are using, and also the size of the processor.
Okay. Thank you.
Okay. Others, any doubts? Did everyone understood these things? The difference between sequential access and random access? Okay. So now we'll try to write the programming. And also here theory is there. Just go through the theory, whatever we discuss, same. What is the sequential access memory, random access memory, and FIFO and LIFO comes under sequential. Okay. Volatile memories, non-volatile, synchronous, asynchronous. What is meant by single data rate? Single data rate means 1 byte of data for each clock cycle. Double data rate means 2 bytes of data for each clock cycle. That means we can send more data for single clock cycle. So there will be versions. Second generation, third generation, fourth generation. So how many data we can send for single clock cycle? Here 4 bytes of data and 8 bytes of data, 16 bytes of data. So you asked what is the processor speed, right? So that totally depends on the clock cycle and how much data we are transferring. That's what we call as a data rate. Based on the data rate also we can check the clock speed. Okay. So DDR4 is commonly used in memory in laptops and servers, which works at a very high speed memory data processing. And also what is meant by ROM, programmable ROM, erasable, programmable, electrically erasable, and erasable alterable. But these things are designed only in the industries. Okay. So, and for the open source, we have double data rate and also FIFO memories. Okay. So first you need to understand the basic idea like how to design a memory. Once you know like just how to write the data and how to read the data from the memory, you will understand any type of memory. Same process for all the memories or protocols, whatever. Okay. So first of all, memory can be included in a design in two ways. One is instantiating a predefined module and modeling with the two-dimensional arrays. In Verilog HDL, I already told you the memory is a static. That means once we declare the memory, we cannot change its size. Okay. But in system Verilog, we have dynamic memory and also associative memory. Dynamic memory means we can resize. If the memory is not sufficient, the storage is not sufficient, we can resize the data at runtime. Okay. But here we cannot resize. It's a static. Whatever the declaration time we just declare the size of the memory, it will be same for whole process. Okay. So this approach is mainly used for simulation purpose. It can also be used for synthesizing. Okay. Next, here if you see how we create the memory. Module, memory, and reg. Here this is how we create the memory. It's a two-dimensional memory. Two-dimensional memory means there will be number of rows and number of columns. Three-dimensional memory means number of rows, number of columns, and number of pages. Okay, so you can use either single dimension or two-dimensional memory. Till now, whatever the designs we used for counters, registers, whatever, we use single dimensional memory. Okay, and here two-dimensional means 7 down to 0 and 0 up to 1028. Here, if you go to system Verilog, in memories also will have the packed memory, unpacked memory, like the different types will be there in the static. Okay, but here no need to discuss now the classification of static memory. Anyway, we will discuss in the system Verilog. Okay, so here 7 down to 0, 7 down to 0 and 1023. 1023 will be the depth. Right side one will be the depth of the memory. So there will be 1023 locations from 0, 1, 2, 3, 4, 5, 6 till 1023 location. In each location, it is going to store 8-bit data. So here's 0 to 7 or 7 down to 0. Here also 7 down to 0, 7 down to 0, 7 down to 0. Like that, each location it will be storing 8-bit data. Okay. Now totally how many number of locations are there? 1024 locations are there. In each location we are storing 8-bit data. Okay. So memory of 0 sending the data here, 8-bit data, and memory of 4 we are passing this data. What type of memory it is? RAM memory, because sequentially randomly we are accessing the memory. First we are accessing 0th location and then 4th location, but sequential access memory like FIFO or LIFO we cannot access like this randomly. You need to start from 0, 1, 2, 3, 4, like that sequentially we need to access. Okay, and here if you want to store 1024 number of locations, the data if you want to store, we need to write for each one memo of 0, memo of 1, memo of 2, memo of 3, like that. For each location we need to store the data, or else in Verilog HDL we have a $random, right? By using the $random we can store the data randomly, but we cannot control the data. Suppose example, here 1023 locations are there, but in real time do we use 1023 locations? Whatever the RAM or ROM you are designing, maybe you will use 100 number of locations. 1023 number of locations are not required. Okay, you want to use only 0 to 100 locations. In that case we need to control. In Verilog also we have few expressions like how to use minimum value, maximum value, minimum to maximum, like that we can consider. But in system Verilog majorly we have constraints topic where we can control the size of the memory, like particularly what memory locations you want to use. Suppose particularly even number of memory locations you want to use, or in this 1024 location particularly you want to use second location, fifth location, 10th location, 14th location, like that particularly. So these things we can design in a system Verilog easily, but in Verilog we can't do that. Okay, we need to use normal $random, or else hard coded values we need to assign like this. Okay, so this is how we can just design a memory. We didn't written any write and read operation. Okay, we just assign the data. Clear everyone till here? Everyone clear till here? Okay, next. So initializing memory in Verilog. Memory can be initialized by reading data from an external disk file. This is mainly used for simulation and test benches. Verilog functions for memory initialization. So these are the few functions or system tasks we can call, or simulated directives we can call. Okay, $read mem binary. So that means you are reading the data from the memory. That too in a binary. B means binary. H means hexadecimal. D means decimal. O means octal. Like that. Okay. First, you need to mention the file name, the design name. So, which memory design you are using, from which memory you are going to read the data. Next, what is the memory name, mem name? That means here 7 down to 0, MEM we put, right? MEM is the name of the memory here. Okay. So that is what the memory name we need to mention. Start address, stop address. Suppose 1024 locations are there, but 1024 locations we no need to read and write the data, okay, or read the data. Suppose if you want to read the data from 100 to 200 locations only, then you can mention start address as a 100, stop address as a 200. So particularly 100 to 200 number of locations data only we can read. Okay. Next, $read mem h hexadecimal format. We can read the data in hexadecimal format. If you want to read entire memory, you don't want to put any control data like start address, stop address. If you don't want to mention, then you can read entire memory from 0 to 1024 locations. Okay, so these functions are helpful for loading test patterns into memory during simulation. And how we can design a memory. So before whatever we have seen here, creating the memh $random $read memh, how we can read the data. So here we have written mem.dat, the file, memory file, and name of the memory. And here we didn't mention any start address, stop address. So total 1024 number of locations it is going to read the data. Okay. And second one, if you see here, 200 to 50. That means 50 to 200 number of locations only we are able to read the data. Okay. Particularly stop address and start address. And any doubt still here?
No, Present.
Okay. No doubt, sir.
It's clear.
Okay. Next, single port RAM with a synchronous read or write. Single port means what? Single operation. Four port in the sense 4 type of operations will be there. Like similarly, RAM input. Suppose this input is related to one particular RAM1. Like this, with same main module, we can create second port called RAM2 and third module called RAM3. Like address 1, address 2, address 3 will be there. 3 type of address. In each address, there will be again particular memory size. Okay, like the data 0, data 1, data 2, like that. 4 port, 3 port. Okay, here single port. Single port means only one port list will be there like this. Okay. So address, data, clock, read, write, CS. CS is a control signal, chip select. We can call as a chip select, the control signal. So input address is a 9 down to 0, so 10-bit address, and clock, read, write, CS, and in out data. Data will be in out. And here we are creating the memory 7 down to 0, mem 1023 locations. Okay, total 8 down to 1024 locations. Assign data is equal to whenever chip select and read is high, we are going to read the data. Okay, so both are high means what? Here it's a true condition, high. Here it's a false condition, 0. High means this data output will be assigned to the data. Data out is a temporary variable. So we are storing the data in temporary. The temporary data will get assigned to the main data whenever read is high. Whenever read or chip select is not high, it will be 0. That means output will be assigned with some high impedance value. Okay. So how we can do the write operation first? Mainly you need to understand how we can do write operation and read operation. So here, always at the rate of posage clock, if CS high, write is high, read is low, we are doing the write operation. Write operation means what? Here is the memory and locations. 0th location, 1st location, 2nd location, 3rd location, 4th location. Okay. So here in 0th location, you want to write the data of 50. Okay. This memory name I am considering as MEM. Name of the memory is MEM. Okay. So MEM of 0, 0th location. MEM of 0 is equal to 50. So I am storing this 50 to inside 0th location of memory. Okay. Like that you want to store the data some 16 into 2nd location. Okay. So what you need to do, MEM is the name of the memory. MEM of 2 is equal to 16. So this 16 is assigned to the mem of 2. Like that 4th location, you want to store the data of 28 into the 4th location. So MEM of 4 is equal to 28. Okay. So this is how we can write the data. But in design, we don't put these values, right? These values will be taken from test bench. Okay. But in design, what we need to write? In design, we need to write mem of 0, 1, 2, 3, all, what all these, nothing but address. Okay, addresses we can call. So mem of address is equal to whatever the data. What is the data here? Data input, which we are getting from test bench, data input. Okay, so mem of address is equal to data input. This is what write operation, whether you use for RAM, ROM, FIFO memory, whatever the memory, it's a write operation. Okay, understood everyone? Clear?
Yes.
Then what is the read operation? How we can read the data from the memory in terms of Verilog program? Same memory, 0th location, 1st location, 2nd location, 3rd location. Suppose here I am storing the data as a 65 and here already stored the data as a 32 by using write operation, and here already stored the data as a 16, here 25. Okay, so I want to get the data of 32. I want to read the data from 1st location. I want to read the data from 1st location. So that particular data, where it will be getting this data? Data output data is equal to which location you are going to read the data? Mem of 1. So mem of 1. So what data is there in mem of 1? 32. So into this data, 32 will be getting. Okay, like that from third location, you want to read the data of 28 from third location. So data, output data is equal to mem of 3. So what data is there in mem of 3? 28. So that 28 data will be stored in the data out. Okay. So what will be the final expression which we want to write in the design? Output data is equal to mem of address. So whatever the address, according to that particular data will be stored in the output data. Okay, clear everyone how to use the write operation and read operation?
Yes,
I
ma'am.
have one doubt.
Tell.
Ma'am, why we are using D out?
D out, because here we declared as a data out, D out, right? It's a temporary variable. We are directly not storing into the main data. First, we are storing into the temporary variable. Whenever the CS chip select and read is high, then this D out is getting stored in the main data.
Got it, ma'am. Okay.
Okay, clear everyone? We will do simulation for this. Everyone clear? Any doubts? Roshini, Sumalata, Vinita, Manoj, Murlidhar, Sunny, Lahari, Jajim.
Clear,
Clear.
ma'am.
Ma'am, I have a small doubt.
Yeah, tell.
Ma'am, actually, we are using both always and assign the same module, right? But assign is a continuous assignment statement and always is a procedural assignment statement, right? Can we declare like this?
Yeah, both we can use in the same module. We can use separately. Assign is a separate block. Always is a separate block here. But this assign you cannot use within the always.
Oh, so we can use both continuous and procedural assignment in the same
In the
module.
same block, in the same module you can use, but within the always, that means within the procedural assignment statement, here you cannot use assign,
Okay, ma'am.
and here within the
Thank you.
always also we cannot use assign. And another thing is here data is declared as a wire. Okay, but this data cannot be written here as a output side, because we are using always. Whenever we use always, this data will be must be declared with a reg data type. Okay, so that's why we have created one temporary variable, and then we are creating the temporary variable with the reg, and here we have stored the data in that. Okay, and this data will be continuous assignment statement which we used for assign.
Okay, ma'am.
If you don't want to use this statement directly, this data can be declared as a reg, and this data you can use directly here.
Okay.
What is the need of chip select, Prashanti? CS?
Chip select means suppose here in memories, whenever we consider suppose 1024 number of locations are there. 1024 locations cannot be target with a one single output. These locations can be target to multiple number of outputs, multiple destinations. So these multiple destinations can be controlled with a decoder, first decoder, second decoder, third decoder, and fourth decoder. To select this particular decoder, we use chip selector. Suppose here this particular memory is storing from 0 to 250 number of locations, or 256 location. 1024 means how many 256 locations will get? Mostly 4 256 locations will get Here 250 locations, here 256 locations, here 256 locations. Okay, so 1024 is divided into 4 parts. But in these 4 parts, which memory you need to access? Means by using chip select, we decode that.
How? On what basis?
Chip select is just what is the decoder logic?
Yeah,
What
it
is
will
that?
select. It will according to our input that
That
one.
particular output
Yeah.
will be selected, right?
Select.
Here we will
Yes.
give the input. Okay, chip select. Here chip select can be any bit, like a 2-bit size. 2-bit size means
Okay.
00, 01, 10, 11. So 00 means which one should select first memory. 01 means second. 10 means this. 11 means like that.
Okay. Yeah, got it.
I will share you some reference book for these memories, so you will get understand more. Okay, clear everyone till here? Any doubts? No? Okay. Next, single port RAM with a asynchronous read or write. So synchronous, and what is the difference between asynchronous? Here we have written synchronous. That means here write and read operations are dependent with the positive edge of the clock. Asynchronous means we don't use clock. We use like this: address, data, read, write, CS. Here also address, read, write, CS. That's what asynchronous, read or write. Remaining all same. Just go through that example.
Ma'am, one more doubt. Like we are speaking about synchronous and asynchronous, right? When we are using always at pause edge clock, then we consider it as synchronous. And whenever we use always at pause edge clock or pause edge clock reset, then it is asynchronous, right?
Pause edge clock reset. Whenever the
Yeah.
reset, reset also, if you use within the always, that is a asynchronous.
Okay. So
If you write
asynchronous
reset,
we can use either way, right?
either
Either we can use pause edge clock
synchronous or
or pause edge reset.
negate. Yes, passage or
Uh,
negate, both you can use. If you use passage, the output will be changed with respect to the positive edge. If you use negate, the output will change with respect to the negative edge. Both are same.
and here in the asynchronous read or write, ma'am, can you move other slide where we have? Yeah, here we are using as we are not using clock, right, for the
Yes.
asynchronous.
Here
Okay,
we are
so
not using clock or reset. Both are not using. Just based on the read and write, we are telling it as a asynchronous. If you use a clock and reset, in that case, asynchronous means you need to put reset here with the clock.
okay,
So what happens in that case? The output will be changed whenever the reset is high. It will be not dependent on the clock. Normally output will be dependent on the clock. Output will be changed with respect to the positive edge or negative edge only. But if you write asynchronous reset, whenever the reset is high, the output doesn't wait for clock edge. Whenever it is reset is enabled, automatically it will be reflected to output.
okay. Ma'am. So in our asynchronous example, we don't need clock, so we are using other variables, right?
Here in next example, we didn't took the clock and reset. So
Okay,
that's
okay,
why we are
yeah,
using. If in that case, if
okay,
you take clock and reset, but still asynchronous means, then you need to mention reset in the always block.
okay. Thank you.
Ma'am, one doubt.
Yeah, tell.
Why two always blocks are required?
You can write two always block or single always block. That's not a problem. Here we have written separately. One is separate for writer, one is for reader. If you want to write both in a same, then what you need to do? If else condition. If CS and write and read is a 0, then mem of address equal to data. Else CS is high, write should be high, read should be high, write should be low. In else case, then you can write the read operation.
Okay.
So what is the design and test bench? Both are different. Huh? Data out, data in address. Both are different. Okay, I will write separately. So if you want to check with this, just try write a test bench and just check. Here both test bench and design both are different. I will write separately. Module test bench. What are the inputs and outputs? Data is written as initially address I am considering as 9 down to 0 now. I'm writing $random. At 0 simulation time, write equal to high. Write equal to high. Next, read equal to 0. And here, write equal to 0. Read equal to high. What is the condition here? Chip select is high and okay. Right, dollar monitor. FIFA example we will discuss in the next session. Address and data put in decimal, so you can understand easily. Clock. Okay. Any mistakes? Correct. Huh? Data is not valid. 19th line.
In the 7th line, it is in out you have written.
Because here data is input side, but
in 7 line 7.
Here data is not only output. Here we have written input to this always block. That's why we have written as a in out. In this case, it will work as a input and also output both.
Yeah. Okay.
The first line. Else we can write.
The module you didn't mention the data D out, right?
Where
At first line, in fourth line. You didn't mention
fourth line.
Yeah.
It's a temporary variable. not
So
input
no
or
need.
output. No need to
Oh,
mention port list. I will write directly if else condition, not this. Write equal to high, read equal to 0. Memory of address is equal to data input. Data in else data out is equal to memory of address. These are the actual statements we need to mention. So write equal to 1, read equal to 0. Write equal to 0, read equal to 1. Write equal to 1, read equal to 1. 4 cases we will get. So if else condition will not work here. What about the default? Um, then in that case we need to take only either write read signal, not both signals. First we'll check with this and we'll see. So data in here data in data in data out. Okay, correct. CS just will remove CS not required, and here also CS not required. Syntax here CS I'm removing. Where is the error? Test bench 14th line. Always hash 5 clock equal to not clock. What is the error? Did you find any error here?
Data should be output rich.
Data should be output rich. Okay.
In if statement, it won't allow with the comma, right? 14th line.
Yeah. Here we can do, then we need to put semicolon. We can put comma also. That's not a problem.
No, Shanti, checks
Like
only one, not
it,
only one.
in the it will be a condition, right? If keep comma, how it will work now?
Use the and or operator.
Data input data is not randomizing. Initially address equal to 292 and data input equal to 1. Data out is not printing here. Data out. Write is equal to high, read equal to 0. Data input is writing into the memory of address. We'll check with the one condition. Write signal. Okay. Write is high. Write operation. Else read operation. Not getting. RAM 3. RAM 3. Data auto. Data in address write. Select to chip select. Okay. We'll say data X. Data audio we can't mention here. Okay, once a check from your side, I will also check and I will try some more examples on Friday. Okay. Any doubts still here? On Friday, we'll work on FIFO and these memories and finite state machine. Okay.
Ma'am, one doubt. Like in this memory code, can we do for random memory also?
Yeah,
Now
both.
we are doing
So
sequential, right?
the random memory and ROM both are same, RAM and ROM. But in industry, they will have the different methodologies for volatile, non-volatile. Those things we can't do here to store the data permanent or temporary. Okay, but memory in the sense just writing the data and reading the data, right? It is same for all. So RAM and ROM both are same. But if you go to FIFO memory, it's a sequential access. And that too, there we need to calculate the depth, whether the memory is full or empty. We need to check the conditions. That would be different. But write read operation is same for all, whether it's a RAM, ROM, FIFO, LIFO, even DDR also it's the same.
Okay.
Okay.
Okay, ma'am. And one more small doubt. Like in real time, we will have setup and hold times, right?
Yes.
Do we declare those setup and hold time in our coding, Verilog coding?
No, we don't check the setup and hold times. As a verification engineers, we never work on those timing analysis. There will be separate team, DFT team will be there, and STA team will be there, back end clock analysis team. So they will work on circuit faults separately. We just write the test cases and verify whether the test is passing or not. Internal synthesis, we never care about the synthesis. I mean, internal stacket
Oh,
faults.
okay, ma'am. So the setup and hold time is completely dependent on the real time device. So our verification engineers can't control over that. So DFT team will work on that, correct?
Yes, not only DFT team, logic synthesis team will be there, gate level simulation team. Those team also work with stacket faults.
Okay, ma'am. Thank you.
Okay. Regarding static timing analysis, you can discuss more clearly with the PD engineer next week from this 15th onwards. Okay.
Okay, ma'am.
Any other doubts? Others? Okay, that's it.